Hi, this is a video about free fall. That's where something's falling. Let's say you jump out of you parachute out of a plane, and before the parachute, you open your parachute, you're in free fall. This is a special case of the kind of velocity and acceleration formulas that you would have covered before you get to free fall in a physics textbook. This, of course, video is cued to Young and Freedman's University Physics, section 2.5. The velocity equations are in section 2.4, and they include equations like the velocity, straight line velocity, the v2, the velocity after a certain amount of time, equals v1, the initial velocity, plus the acceleration, and this formula assumes constant acceleration, times the amount of time. It's a fairly straightforward formula. Well, let's say you're in a helicopter hovering a certain distance, constant distance above the Earth. Let's say it's just hovering. And you have a rock, and you just drop the rock. Well, this is going to be a special situation. So the velocity, let's say that you want to know how fast that rock is going to be going after 5 seconds. Now, no matter what you've been told, all things fall at the same weight, at the same speed, or at the same acceleration as they fall toward the Earth. And that's 9.8 meters per second squared is the acceleration of anything. Whether you drop a truck out of a plane or whether you drop a rock out of a plane, it's going to fall at the same acceleration. I was watching some movie, I think it was The Kingsman I was watching, and after the girl jettisons the metal casing that she had on her back when she floated way up to the atmosphere, I noticed that after she ejected from that, she fell at a much faster rate than the metal casing she was with. And I couldn't figure out what was going on there because everything falls exactly the same, no matter how heavy it is. Now, somebody out there, some smart aleck, is going to say, what about a feather? Well, a feather falls slower, not because of this being wrong, but because of the air resistance. In a vacuum, in space, well, anyway, in a vacuum, a feather and a Mack truck fall at exactly the same acceleration and exactly the same rate. And so this is a principle. So that's something to keep in mind. When I drop this rock, if I drop it from a helicopter that's just hovering, then its starting velocity is 0. Its acceleration is 9.8 meters per second squared, or 32 feet per second squared if you're just into English system. But in any case, we're going to say it's negative. Why? Because we're going to consider up to be positive acceleration, and we're going to consider down to be negative acceleration. And so since gravity is pulling the rock toward the Earth, we're going to consider that negative g, or negative 9.8 meters per second squared. So this collapses. V1 is 0, and a is negative g, or negative 9.8 meters per second squared. And so basically, ta-da! The velocity at any point after you let go of the rock is going to be negative 9.8 times the time. So after 5 seconds, if it doesn't hit the ground in 5 seconds, the velocity is going to be roughly, let's round it to 10, negative 50 meters per second is how fast that rock's going to be falling after 5 seconds. Now, of course, if you'd have thrown the rock down, straight down, we'd have had to have an initial velocity as well. And as I said, the farther up you get away from the Earth, the lesser the constant becomes. 9.8 is close to the surface of the Earth. It becomes less the higher up you go. So the same applies to the distance formula. So if you consider 0 to be where the helicopter is, then the x1 cancels out. If you consider the velocity to be 0 when it starts, then 0 times t cancels out. And so after 5 seconds, how far is that rock going to have traveled? Again, it doesn't matter how heavy the rock is. After 5 seconds, the rock will have gone 1/2 times negative g t squared. So that's going to be 5 squared. If you're doing 5 seconds, that's 25. 25 times, I'll round it to 10, 250. Half of that is 125. So roughly it will have fallen 125 meters. Anything will have fallen roughly 125 meters after 5 seconds of free fall, including you if you jump out of an airplane. And don't jump straight down, but just kind of start from 0. This is basically what this section is about. It's very simple. So if you start from a distance that you're calling 0 and a velocity of 0, then after any particular amount of time, the distance that rock will have fallen is -1/2 times 9.8 times the time squared. Easy peasy.